This is the Mat114 final exam review. We'll do questions 11 through 20 in this segment. So first of all, we're given a number line. We see that there's an arrow at the end, which means it's going to keep going, and a solid circle at this end, which means that the 2 is included. So inequality notation is that x, again, how do we want to write this? Use the following syntax. I guess x, right? They don't say, but x is living in this area. X is any number in here. So what we do for our syntax, we can put this as going to be that x has to be greater than or equal to, right? Larger than or equal to 2, right? That's what that's saying. Save. For interval notation, click here, get our intervals. The 2 is included. Now when we go off to infinity, we always have a parentheses on that side. So we're going from 2 all the way to positive infinity. So let's get to the other side over here. So we just keep going. Okay. So that really is from, oh sorry, it's a -2. I should have been paying more attention. So we're going from -2 to positive infinity. It's going to look like that. And of course we're going to have to be greater than -2. Okay, let's come back in here, edit this a little bit, put our -2, and over here put our -2. Okay. For this one, the open circle means that it's not included. So it means we're going to have our parentheses here. We're going this way. This is going to take us to negative infinity all the way to -2. Okay, so we'll do the interval notation first. Sometimes that's easier. And notice it always goes from smallest to largest. So we come here for our intervals, and this one's, oops, let's clear. It's not included. We need parentheses on both sides. So we've got negative infinity, and then we go till -2 again, not positive 2, -2. Okay, so that's our interval there, and here x is living down in this, the bottom part, so x is less than -2. Or inequality, it's less than, strictly less than, not equal to, okay? -2. There we go. And this final one, we're going between 2 ends, so we have a stopping point. And again, so this solid dot is included, so we put a bracket at this end, a square bracket. This +3 is not included, so we put a parentheses. Okay, that's going to give us the interval notation. Our intervals, we need a close to an open, and so we go -3 until +3, bracket for the closed, parentheses for the open. There we go. And we do sort of the same thing here with the inequality. The x is in between the 2, so we're going to say -3 is on the smaller side. It is included, so it's less than or equal to x. And then x is less than, strictly less than +3. Notice I don't have the equal to there, so that's very important details all the way along. All right, it's 11, interval notation, inequality notation. Now we've got some function notation, and we are going to be looking for some points. So evaluate f of minus 2. So here's the f function, here's a g function if they give us that, and here's the p function. Okay, so we're going to do multiple things with these. F of minus 2 means we come to where x is negative 2. We go up or down until we hit the graph, and then what we do is we read the y value. So negative 3 is our answer. Put that in. It's negative 3. The second question is, notice the 5 is on the outside, so that's a y value. That's when y is 5, what is x? Notice it's saying what is x when y is 5. So we come up here to where y is 5, go over till we hit the graph, and then now we read the x. The x is going to be 5 as well. Straightforward enough. So input is on the x-axis, output is on the y-axis. Let's go ahead and clean that up. There we go. And now we're going to look at our g function, g of 14. Now g is, we've got inputs and outputs, inputs, outputs. So we come in, 14 is an input. We now need to know what is the output that goes with it. It's negative 5. Okay, so that's what goes in there. 14 is the input, negative 5 is the output. Notice this next one, this is an output, so we're looking for when is the second coordinate 58, what is x? So we're looking now for a second coordinate. Now it's all the way here to the end, right? Keep looking. The second coordinate is 58, what is the x? X is 85. So that's what we put in. It's just a lookup, 85. Got to know where to look in the right places. Okay, let's clear that out. Now we're looking for the h function. Oh, where's it? Oh, I missed it. It was down here. There's one more function. So h is down here, and we're given a formula, so we're going to have to plug it in. So evaluate h of 2. That means put the 2 in for the x. So we're going to have 14 times 2 minus 8. That's 28 minus 8, that's going to be 20. And then determine x when h of x equals 188, so that is, the answer is 188, right? It's this one here. So we say 188 is equal to 14x minus 8. Now we need to solve. So we'll add 8 to both sides. This now becomes 8 and 8 is 16, carry the 196. And then we'll divide both sides by 14. And I think that happens evenly, so we're going to get that x equals, let's go ahead and pull up the calculator. I can't remember that one, but I think it is an even 196 divided by 14 is 14. That's what I was thinking, 14 squared. Yeah, okay, 14 times 14. So equals 14. So we can put that in there. And then finally, let's go ahead and clear those off. So they're all correct. We're evaluating P of 200, and again, we're just looking in a table. So here's P102, so that means that's an input, so we're looking along, that's a T value, so we're looking 102, what is the output? 23 is our answer. This second one, 75 is the output, so we're looking in this second row. I should go with the red. We're looking for 75 down here, and then our answer is going to be up here, 67. And that's all there is to this one. Submit them, and hopefully we got them all right. We'll check back. Good. 13. So now let's see what we got going on here. We've got a practical domain question, practical range. Remember, we kind of got to understand the story. So we've got a function. This tells us what's going on. We're taking 12 times t. It's distance in miles that we would travel bicycling, t hours. Assume you can bike no more than 11 hours. Get too tired. I can't make it 11 hours, but find the practical domain and practical range. So you can make it 11 hours. Well, what's your practical domain? Domain is the input, time bicycling, and so that is going to be our input value, which is t. Okay. The most we can do is 11. You can't really do negative time, but you can just not go. Maybe that's what I would do. Sit on the couch and not do anything. So 0 to 11, we'll say, is our possibilities. Now, when we look at our practical range, what we do is we put these two endpoints in. So if I don't do any time on the bike, how far will I go? Not very far, right? So I find m of 0. That's 0. And then I find m of 11. Okay, so that would give me the other extreme. And 12 times 11 is 132. 132, right? Yeah. And so that's my practical range. Now, mathematically, we could keep going to infinity, but physically, we just can't do it. So we either go 0 miles, or we go 132 miles, or somewhere in between. And this is our function m of t. Okay. Practical domain, practical range. What does a story tell us is going to happen? I didn't like that. Oh, include your units. Yeah, read the question. Include your units. So this is hours. T is in hours. Down here it's in hours. And our practical range is in miles. That's why we do the check. I want you to be sure to, yeah, now we're all okay. We're all okay. We know what we were talking about. We just need to have the units. Clear that out. Move on to 14. 6 of these, we'll do a few of them. We'll see maybe all of them. Okay. Evaluate the following functions. So notice all of these we're just plugging in a value for x. So this -8 goes in for the x. Both of the x's. Right? There's two places to plug that in. So we're going to have 3 times -8 squared minus -8. You can just plug that in, but a negative and negative make that a positive. So we're going to add 8. -8 squared is going to be positive 64. And then 3 times 64 plus 8. Good time to pull out the calculator. 3, could have done it at the beginning too. Plus, let's see, let me clear that out. 3 times 64 plus 8. 392. Okay. G of x over here. Again, we're just going to plug the -3 in for the x, so we get 5 over 3 times -3. So it's going to give us 5 over 9. And it's going to be a -9. You could put it in the bottom or you could put it in the middle. You really can do it either way. and it is a reduced, it's reduced. Can't reduce it anymore. 5 divided by 9. I got the negative in front. There we go. Absolute value, so stick -6 in for the absolute values. So you've got the absolute value of -6. Well, the absolute value makes everything positive, so that's going to be +6. This one is oftentimes the one that's people will struggle with because I could plug the 4 in, but there's no place to plug it. It's the constant function. It doesn't matter what x is, y is always -5. So this is always going to be the answer. Constant function, -5. Okay. Down here, we go ahead and we plug in -2 for r, so I get 2 times -2, and then I raise all of that to the third power. So watch your order of operations. We have to do inside the parentheses first. 2 times 2 is 4, so we get a -4 to the third power, so that's 4 times itself 3 times, -4, so it's actually going to be -64. 4 times 4 is 16. 16 times 4 is 64. Finally, we get down to our last one, and we're going to plug in a -9 for this end. So we get 1 over -9 squared. So we do the square first. -9 times -9, that's 81, positive 81, so 1 over 81. And that's a reduced fraction. Okay, let's clear all this out, submit it. Hopefully we get it all right. There was a problem here. I thought there might be a this calculator entry. I got 3 times 64 plus 3, other than plus 6. Yeah, so it's good because they show us right here. So let's try this again. It was supposed to be 3 times 64. No. 3 times 64 plus 8 gives us 200. Okay, 200. So watch your entries into your calculator. The calculator's not magic. You put the wrong entry in, you'll get the wrong answer out. Number 15. So we're given a function, we're asked to evaluate it for here. So it's kind of like a composition. So this is going to go in for the input. So what I like to do with a function, what do I have? I have f of x. What is f of x? It's f of input. So I just take the x's out. And then so I'm going to rewrite this not as 3x plus 6, but 3 open parentheses plus 6. So 3 input plus 6. Okay. And then so what is going in for that input? X minus 7. So x minus 7 goes in here. Now they want us to simplify, otherwise we'd be done. This is our new function, but they are going to want us to, let's go with this, to distribute, then combine like terms. So we get 3x minus 21 plus 6. These are like terms, so we can combine them. We get 3x. Signs are opposite, so we actually subtract them, right? 21 minus 6 is going to be 15. And since 21 is a larger value, it's negative, so it stays negative. That's our answer. Syntax is okay, likes our answer. We're in good shape. And again, you can always try a similar one, practice. See, that's something very similar but different numbers. So give them tries, give them several tries until you feel real comfortable and confident with what you're doing. Oh, a lot of these. Okay, so we're talking slope, vertical intercepts, and horizontal intercepts. So first of all, let's get some. So slope is the number in front of the x. So remember, because we've got this y equals mx plus b, the m, that's our slope. That's what we're talking about. That's the steepness of the line. This value by itself is actually going to be the Y-intercept, the vertical intercept. Okay. And then the horizontal intercept is, we generally can't see it directly from this, but it's what happens when Y is 0. So horizontal intercept, the defining part of a horizontal intercept is that it's some x coordinate with a 0 y coordinate. Vertical intercept is a 0 x coordinate with some y coordinate. And again, that's why if you plug in 0 here, all that's left is b. And the slope is the coefficient, it's the m. It's the number in front of the x. So there's the slope, -3. So take a look at these as we go through. So -3. The vertical intercept, plug in 0 for x, that goes away, so -7 is going to be our vertical intercept. And let's read a little bit more closely. Write your numerical answers as whole numbers or reduced fractions. Okay. Write intercepts as ordered pairs. So we don't want to just write -7. We want to write 0, comma, -7, and we want to have our parentheses in there. Otherwise, it's not an ordered pair. -7. There we go. And then now the horizontal intercept, that's where we've got to actually do a little bit of work. We're going to plug in 0 for y. And then we have to solve for x. So we add 7 to both sides. We get that 7 equals -3x. And then we're going to divide both sides by -3. Some parts of my tablet just don't work so good. So then we get x equals -7/3. And remember, we need to put this in as an ordered pair. So this is the x, the y is 0. X -7/3, comma, 0. So that's that part. It's looking okay. And then what's its behavior? Well, this is decreasing because the slope is negative, so it's a line that's going down. It's decreasing. And again, what we could do is, I'm going to clear this out in a minute anyway, is thinking of it, it's got a y-intercept of -7, so it's like down here, -7. A slope of -3 means it drops 3 and then goes over 1, right? 3 over 1, slope is -3 over 1 if you want, so we come down 3, we go over 1, we come down 3, we go over 1. So it's a line that looks kind of like that, decreasing line. Clear this stuff. And we'll do the same thing and we'll kind of keep moving. So our slope is going to be 9 here because it's the number in front of the x. That's what slope is. It's not always the first number. It's the number in front of the x. That's our slope. 9 over 1. Rise of 9, run of 1. And it's positive. So we could also say right now that's what tells us it is increasing. It's an increasing line. Okay. The y-intercept is 1. So that's this part right here. And again, it's going to be 0, comma 1. As an ordered pair. The x is 0, the y. And then to find the horizontal intercept, well, we've got to put in 0 for y and then solve. So we subtract 1, both sides. -1 equals 9x, cancels, and then we divide by 9. So x is equal to -1/9. And again, we want to put that in as an ordered pair, and it's good to remember as we do this, -1 divided by 9, comma 0. And it's an increasing function. We've already taken care of that part. Good. Now this one, our slope, -8. That's all we have to write, so -8 over 1. It's got a negative slope. Negative slope means it is decreasing. Okay. The line is going downhill. Vertical intercept, now this one, you say, well, there is no vertical intercept, but it's really plus 0, 0. So what does that mean? It means the y-intercept is 0. So when x is 0, y is 0. What's really cool about this is that once we have the vertical intercept of 0, 0, we know that that's also at the same time the x-intercept. So we don't have to do too much work because when x is 0, y is 0. When y is 0, x is 0. There we go. Now there's these last two are our very special case lines. Y equals -5, that means that y is always -5. So that's a horizontal line here. So horizontal lines have a slope of 0. So we have to know that. That's going to give us a 0 slope. The vertical intercept, well, it's going to go right. Y is always -5, so 0, -5. That's all it could be. Oops, the parentheses or the comma. And then finally, for the horizontal intercept, that's why I draw the picture. You can see it's not going to cross the x-axis. It's not going to have a horizontal intercept, so that's where we put the D and E. There we go. And what kind of line is this? Notice it's not increasing or decreasing. It is a horizontal line. And that leaves x equals 3. That's our last thing. And so here's 3. That's going to be a vertical line. X is always 3. And you see that it's got a horizontal intercept, right? But it does not have a vertical intercept because it is a vertical line. And the slopes here is, since it's all rise and no run, it's division by 0. So what we have is its undefined slope, or D and E. What's the vertical intercept? Well, there is none. That's D and E. And you kind of just see, well, yeah, it's not gonna cross the y-axis. But where does it cross the x-axis? It crosses at 3, 0. And what kind of line is this? This is a horizontal line. So that's all the different types of lines that we see submitted. Hopefully we got them all right. Oh, I didn't like something. Oh, it's a vertical line, not a horizontal line, right? You can't have both of these. One is horizontal, x equals 3 is a vertical line. Just wasn't paying attention there. There we go. That's why we got the 2. So you kind of catch yourselves on the exam. They'll give you 2 tries. Look at 17, get a few more, and then we'll take a break. So now we're given 2 points, and we want to get the equation of the line. Y equals mx plus b. So one way we do this is we get the slope first. Remember the slope formula, y2 minus y1 over x2 minus x1. So we've got 1 point, we'll call that x1, y1. And then we could call this x2. Y2. Don't write real good on those. So we'll take the y's go on the top, so maybe -6 minus -2. And in the bottom, we'll take our x's. So I start with -6, so let's start with -8. That's the main thing you have to do. And then I've got an 8 here.